Hello students, good morning. 12th standard chemistry, unit 2, P block elements. Dear students, in this unit we have been discussing the general trends in the properties of P block elements and we have completed majority of the concepts. Finally, in this video, the concept we are going to see is allotropism. So what we are going to see now? Allotropism. We are going to define allotropism and also we are going to see the various allotropes of different elements. Is it clear, students? What is the concept of today's video? It is allotropism. Let us move on to the concept. Okay, dear students, in order to have a clear picture about the process of allotropism, here I have taken a number of pictures. Look at the first picture. What it is? Yes, it is the picture of diamond. Then second one, here it is the picture of a pencil, and the major constituent of pencil is graphite. Okay, a special chemical substance called graphite is the major constituent of pencil. Then third, this ball like structure is called as fullerene, and finally this tube like structure is called as carbon nanotube. Is it clear, students? How many pictures I have placed? I have placed 4 pictures. A picture of diamond, then graphite, this is graphite, and this is fullerene, and finally this is carbon nanotube. Okay, so why these pictures I have placed means all these are the types of a same element. Is it clear, students? Diamond is another form of carbon, then graphite is another form of carbon, fullerene is another form of carbon, carbon nanotube is also another form of carbon. So all these things are the various forms of a same element, or we can say a same element can exist in more than one physical modification. So that property of an element is called as allotropism. The ability of the existence of same element in more than one physical modification is termed as what? It is termed as allotropism. Is it clear, students? A single substance exists in many forms, whether it is in the crystalline form or in the molecular form or whatever form it may be, but the same element exists in more than one physical state. That is called as allotropism. Now look at the definition. This is the definition of allotropism. Let me read. The property of existence of same substance in more than one crystalline or molecular form in the same physical state. The physical state will be the same. If it is a solid, it will be solid in all the cases. If it is a liquid, it will be a liquid in all the cases. But it will exist in different modification. Okay, so what is allotropism? It is the property of existence of same substance in more than one crystalline or molecular form in the same physical state. That is called as that ability is called as allotropism, and the various forms are called as allotropes. The simplest example is this diamond, graphite, fullerene, carbon nanotubes. So these are the allotropes of carbon. Is it clear? Okay, and some more examples are given. For oxygen, there are 2 allotropes available. Those are dioxygen and ozone. And for sulfur, there are many forms available, but here I have taken 2 forms, rhombic sulfur and monoclinic sulfur. So those 2 are the allotropes of which one? Sulfur. Is it clear, students? Are you able to understand what is called as allotropism? Same element exists in more than one physical modification, but their physical state will be the same. Okay, ma? Okay, ma. Then in the next slide, I have placed the allotropes of various elements. Look here, what is given? First, boron. Boron exists in amorphous boron form, then alpha rhombohedral, then beta rhombohedral, gamma rhombic boron, then alpha tetragonal boron, beta tetragonal boron. So these are the allotropes of boron. Then for carbon, the allotropes are diamond, graphite, graphene, fullerene and carbon nanotube. Then for silicon, the allotropes are amorphous forms of silicon, then crystalline silicon. Then for germanium, there are 2 allotropes possible. What are they? Alpha germanium and beta germanium. Then for tin, the allotropes are gray tin, white tin, rhombic tin and sigma tin. Then for phosphorus, the allotropes are white phosphorus, red phosphorus, scarlet phosphorus, violet phosphorus, and finally black phosphorus. These are the allotropes of phosphorus. Then for arsenic, yellow arsenic, grey arsenic, and finally black arsenic. And antimony, blue white antimony, yellow antimony, and black antimony. These are the allotropes of antimony. Then for oxygen, as we have seen in the previous slide itself, there are two allotropes available. What are they? Dioxygen and ozone. Then for sulfur, the allotropes are rhombic and monoclinic sulfur. Then for selenium, the allotropes are red selenium, grey selenium, black selenium, and monoclinic selenium. Then for tellurium, there are two allotropes available. Those are amorphous tellurium and crystalline tellurium. Is it clear, students? So in this video, what we have seen, what are called as allotropes and its definition. What is the definition of allotropism? The property of existence of same substance in more than one crystalline or molecular form in the same physical state, and the allotropes of various elements also we have seen. Okay, mama? Okay, go through the video and have a clear understanding about the concept of allotropism. Thank you.